Hi everyone, welcome to this another video on Python coding. So in this video, we are going to push our abilities a little bit, and we'll go towards more towards solving coupled equations. And these are the kind of equations you will see a lot in this class, especially in the first part, and even in your first homework. So what you're seeing here is there are two variables f and g, and we have these equations d square f by dx square is equal to f and d square g by dx square is equal to minus f. And we have been asked to find a solution to these with the boundary conditions given on the right. And this equation, I will just show you the solution is pretty straightforward. So again, you can basically see you will write this f as a form of um, c1 cos sinh of x, c1 sinh of x plus c2 cos of x, because it does not depend on anything else. This is what it really depends on. And then we have to find the values of basically c2 and c1, right? So we'll start with the first boundary condition, f at x is equal to 0, which is c1 sinh of 0 plus c2 cos of x. And so what you really get is this is equal to 1 from this boundary condition. And this goes away because sinh of 0 is 0. And so C2 basically becomes, and this is cos of 1, essentially because cos of 0. Let me just clarify this. This is cos of 0 is equal to 1 from this boundary condition. This goes away. So C2 essentially becomes 1. This is the equation, that first value of C2. And then to find df by dx, we'll differentiate the solution, which we know is the C1 sinh cos of x, C1 cos of x plus C2 sinh of x. And then we'll essentially evaluate this at x is equal to 1 and then substitute this to be 0, which is this boundary condition. And we know C2 is equal to 1. So this is equal to 1 from the other solution. So essentially we get C1 cos of 1 because this is equal to 1 and this is equal to 1. We're evaluating this as at x is equal to 1. So C1 cos of 1 plus sinh of 1 is equal to 0, or rather C1 is equal to minus sinh of 1 by cos of 1. Okay, so essentially you get this as your result. And finally, what we did get f is equal to um, sinh of minus sinh of 1 sinh of x by cos of 1 plus cos of x. Okay, and so this is the solution, and we can actually go a little bit further. If you look a bit carefully, you can go a bit further. Is you can say this is going to be minus sinh of 1 x sinh of x plus cos of x cos of 1 by cos of 1. So I multiplied that, and I believe this should be cos of x minus 1. Well, let's just check cos of a plus b formula. Cos of a plus b is cos a cos b plus cos a cos b, or cos a minus b. Let's check cos a minus b formula. And you get cos x cos y minus sinh x sinh y. So this should be basically cos of x minus 1, right? Okay, so this is the formula we find. So this is cos of x minus 1 by cos of 1. Okay, so this is the result we get for f. Okay, now one approach is to now substitute this into g and solve the equation, which I think is absolutely fine. You can definitely do that. Another way to do that is to see that if you add these two equations, so add these two equations, add differential equations. And this isn't like some like difficult thing to see. You can see the right hand side is the same with the opposite sign. So you'll get d square f plus g by dx square is equal to 0. And for the boundary condition, we can just sum them again. So you'll get f plus g at x is equal to 0 is equal to 0. and dy by dx of f plus g at x is equal to 1 is also equal to, sorry, first is 1 because this value is 1. So this summation should also be 1. And the derivative is 0. And the point is this allows us to write this as f plus g. This differential equation is easy to solve. So this becomes f plus g is equal to c1 x plus c2, or rather c3 x plus c4, so that you don't get confused with the other variables. Taking the derivative, I mean, I'll just quickly do this because this is very easy to do. And you'll get this as c4 as equal to 1. So what you really get is g is equal to 1 minus f. Okay. And so this implies g is equal to 1 minus cosh of x minus 1 by 1 minus cosh of x minus 1 by cosh of 1. So this is your value of g. You can solve it with the other way, doing the full differential equation. That's absolutely fine. But I just wanted to give you a quick way to show how to do this when you see these tricks. Something again you can quickly remember. Now let's go further. This is what we get from our analytical results, and this is what we have as our solutions. But now we'll have four variables. So let's discuss what I mean by that. So in our Python code, we'll define y0 as f dy0 by dx as sorry, apologies, y1 as df by dx, or rather dy0 by dx. Okay, and we also know that so this means and we also know that dy1 by dx is equal to d square f by dx square is equal to minus f, and this is equal to minus y of, or plus f or minus f. It's plus f, so it's plus f. Now this is equal to y of 0. Okay, so this means that our first two simply becomes, so you want to say, I'll keep track here, dy0 by dx is equal to dy0 by dx is equal to y1, and dy1 by dx, this is the form that that Python expects, and this is equal to y of 0. Okay. Now we also need two more variables for dg by dx and g itself. So now we'll go there. So we'll say y of 2 is equal to g. Then we'll again say y of 3 is equal to dg by dx is equal to dy2 by dx, right? And d square y3 by dx, sorry, dy 3 by dx is equal to d square g by dx square. And this is equal to minus of f, which is y0. This is minus f is equal to minus of y0. So now for what Python expects, dy2 by dx is equal to y3, and dy3 by dx is equal to minus y of 0. Okay, so this is the four equations that we want, and this is what we have as our boundary conditions. Now we have f at x is equal to 0 is equal to 1. So this means that y of 0, rather ya of 0 in the language of Python, minus 1 is equal to 0. And these are what, this is what Python will expect. Then we have g at x is equal to 0 is equal to 0. And then Python will expect ya, and g is 2. So ya of 2 is equal to 0. So this is what we'll write in Python code. Then we have df by dx at x is equal to 1 is equal to 0. df by dx is 1. So first index is equal to 0. So again, we'll just write 0 like this. And we also have dg by dx at x is equal to 1 is equal to 0. So we'll have a yb of 3 is equal to 0, because dg by dx is basically y3. Okay, so this is a little bit more involved, but hopefully you are following along. Once again, you see this, it's easy to follow. So let's see. Again, I have not coded this before, so I'll code it with in the video together. And let's keep on going and doing this more practice. We'll copy paste. Just modify this code to see if you're able to get the results or not. Okay. So we have the first, let me keep it side by side so it's easy to see. Let's do this. Okay, all right. Hopefully you can all see the two screens simultaneously. So first is y1, then we have plus y naught, then we have y3, then we have minus y naught. Okay, so this is how we have the full equation for VStack, which is what we have. Then let's go here. And these are the boundary conditions. So ya naught minus 1, then ya of 2, then we have yb of 1, then we have yb of 3. Okay, so these are our boundary conditions. Now we again go from 0 to 1. 50 is fine. We have now 4 variables instead of 4 variables because we have y0 to y3, 4 variables. We solve them. So we'll get f as this, solve while y0, and then we'll get g as solve while y2. Okay, so that was the case. And so the solution now should be f and g. So for f, let's use the color B, and we'll just use B for that. And the solution we found was, let me check, that was NP of cosh of xg minus 1 by cosh of 1, right? Not cosh, cosh of x minus 1 by cosh of 1. Then we'll say this is a result. Then we'll also keep on plotting for, let's say, the red color for G. And according to us, this should be 1 minus of that. And then we'll get R naught in this one. Okay. So f of x comma g of x. This is what we're plotting. Hopefully this runs. Let's see. We do get a perfect match. That's awesome. Again, this was I hadn't really coded this before, but we get that match as well. Okay. So hopefully this, you see, like first you systematically lay it out on your notes, and then you basically just transfer it to the code, and we can see we are getting a pretty good agreement even for a coupled system. So hopefully this helps. Let us know if you have any comments, and I'll see you on Tuesday for the next lecture. All right, bye-bye.